Alright, so let's continue for the following example of steam tables. Now we move on for the superheated steam table. Okay, example number 6. Calculate the enthalpy for the following: superheated steam at 10 psi and 275 degree Fahrenheit, superheated steam at 20 psi and 325 degree Fahrenheit, followed by superheated steam at 30 psi and 223.88 degrees Celsius. Okay, so for this particular example, example number 3. Alright, I circle here. So can you see that the unit is in degree Celsius, whereby the unit in superheated steam table is using temperature in degree Fahrenheit, in British unit. So for example number 3, you need to be careful to do not simply use this value straight away. You need to convert this particular temperature value first. Alright, so now we are going to settle this particular problem set one by one. Alright, at the bottom, this particular table, I have extracted all the values from superheated steam table. You can refer these particular values from superheated steam table. Alright, so this one, the first one, 10 psi. So look for the column of 10 psi. Okay, first what you need to do is you need to find for the column of 10 psi first over here. Alright, and then the value of 275 degree Fahrenheit. Okay, so this particular value of 275 degree Fahrenheit, which temperature range that is having in between for 275 degree Fahrenheit? So 275 degree Fahrenheit is in between 300 and 250 degree Fahrenheit. So the value of superheated steam at 275 degree Fahrenheit and 10 psi is supposed to be here. Right? Okay, and then the second one, 20 psi and 325 degree Fahrenheit. Again, look for the column of 20 psi. Okay, and then please make sure that you are looking for the column of H. H is the value for the enthalpy. Don't look for the value for the V. V is meant for specific volume. Alright, and then where does this particular unit coming from? You can look back in superheated steam table. It's supposed to be located at the bottom part of the steam table. Alright, so for example this one. Okay, so 10 psi, this one H, the value of H, and this particular H representing for the enthalpy, and the unit has been written BTU per pound for this superheated steam table. Okay, and then for the third one, this one is 30 psi and the temperature is 223.88. So you need to find this temperature first. What is this value, this temperature value in degree Fahrenheit first? Then you are going to be able to extract the information from superheated steam table. Alright, so convert this particular value and then find the information from superheated steam table, attachment number 3. So the value, after you convert the temperature value, is supposed to be in between 400 and 450 degree Fahrenheit under 30 psi. Okay? Alright, so now let's move on to the following slide. For enthalpy superheated steam at 10 psi and 275 degree Fahrenheit. Okay, so we gather the information that we can get from the superheated steam tables. Okay, so 10 psi, 250 degree Fahrenheit is 1170.2 BTU per pound. And please make sure that you do not leave out the unit. Okay, this particular unit is important because it representing the parameter that you are writing. Okay, if let's say you are putting this one 10 psi and 250. 250 what? What does this value representing? Does this value representing for the temperature or for the enthalpy, and for the temperature which unit that is being using? Is it going to use SI unit or is it using British unit? Alright, so please make sure do not forget to write the unit. Okay, and then 10 psi and 300 degree Fahrenheit, the value is 1193.7 BTU per pound. Okay, find the difference of temperature difference. Okay, on your left hand side, you can calculate the temperature difference. 300 degree Fahrenheit minus by 250, so that's why you will get 50 Fahrenheit. Alright, and then 1193.7 minus by 1170.2, you're supposed to get the value of the enthalpy is 23.5. So this particular area is meant for enthalpy H. Okay, then for every 1 degree Fahrenheit, what is the value for the enthalpy? For every increment of 1 degree Fahrenheit, so what will be the enthalpy? So how you are going to calculate this one is simply by using 23.5 BTU per pound divided by 50. Okay, so you should be able to get 0.47 BTU per pound. Okay, and then after that, proceed to the calculation to solve the problem statement. Enthalpy of superheated steam at 10 psi and 275 degree Fahrenheit. I use this value from 250 degree Fahrenheit because for me this one is easier for me to comprehend and to calculate. Because this one, in between 250 degree Fahrenheit and 275 degree Fahrenheit, this one is an increment of temperature. Increment of temperature meaning that I need to add the value of the enthalpy because it's getting hotter. So I need to add. If let's say I select 300 degree Fahrenheit, it is okay, it is not wrong, but you need to make sure that in between 300 degree Fahrenheit and 275 degree Fahrenheit, 300 degree Fahrenheit is hotter compared to 275. So this particular plus you need to replace with minus. Okay, but then for the problem solution here, I show you 2 plus because the temperature is increased from 250 degree Fahrenheit to 275 degree Fahrenheit. If you want to base by using 300 degree Fahrenheit, it's correct as well, but please make sure that you change the plus to minus, and this particular value need to be changed as well. Okay, so for now, let's take this as basis from this 250 degree Fahrenheit. The value of enthalpy is 1170.2 from here, okay, plus 0.47, this one for every 1 degree Celsius, the increment of the enthalpy is 0.47 BTU per pound. But then the temperature difference between 250 and 275 degree Fahrenheit is 25. Okay, this 25 coming from the difference of temperature. Okay, because this one 1170 is coming from the temperature of 250. So this one is 275 minus by 250. Okay, it's already reaching. Okay, 250. 275 minus by 250. So this one you should be able to get 25. Okay, so add the value and then you should be able to get 1181.95 BTU per pound. Alright, this one, let me erase this one first so that you have a better understanding. Okay, for this 25, it's coming from 275 minus by 250. Okay, so you'll be able to get 25. 275 is the temperature stated in the problem statement. 250 is the temperature given by superheated steam table. Alright, then we move on for the following example. For the following example, enthalpy of superheated steam at 20 psi and 325 degree Fahrenheit. So this particular value of enthalpy at 325 degree Fahrenheit is located in between 300 Fahrenheit and 350 Fahrenheit. So the enthalpy for 300 Fahrenheit is 1191.4, whereby for 350 is 1215.4 BTU per pound. Again, the same steps apply. Calculate the temperature difference between these two temperatures and then calculate the enthalpy difference. Alright, and please make sure that you don't forget about the unit and calculate for every increment of 1 degree Fahrenheit what will be the value of the enthalpy. Okay, so the superheated steam at 20 psi and 3 to 5 degree Fahrenheit, I'm taking the value starting from 300 degree Fahrenheit, it is 1191.4 plus 0.48 coming from here times by 25. Again, 25 is the temperature difference between 300 degree Fahrenheit and 325 degree Fahrenheit. So you should be able to calculate the value and get 1203.4 BTU per pound. Okay, so the third example, enthalpy of superheated steam at 30 psi and 223.88 degrees Celsius. Alright, this one, we need to, this one is the correct equation for you to convert from the temperature degree Celsius to degree Fahrenheit. So convert the value, this temperature of 223.88 degrees Celsius to degree Fahrenheit. So you should be able to get the value at 435 degree Fahrenheit. So again, from the attachment number 3, from superheated steam table, gather the information. At 30 psi and 400 degree Fahrenheit, you should be able to get 1237.8 BTU per pound. 30 psi, 450 degree Fahrenheit, 1261.9 BTU per pound. So why do we gather these two information of these two temperatures? Because the value 435 degree Fahrenheit is located in between 400 and 450 degree Fahrenheit. Okay, and then again, find the temperature difference, find the enthalpy difference, calculate for every 1 degree Fahrenheit what will be the enthalpy increment for this problem statement. So calculate the superheated steam at 10 psi and 275 degree Fahrenheit. You should be able to get 1237.8, okay, coming from this 400 degree Fahrenheit, this particular value, plus 0.482 coming from here, times by 35. 35, oh sorry, this one you need to change the value. This one is not 275. The temperature over here is 435. So please make changes to your lecture notes as well. This one is 435. Alright, 435 degree Fahrenheit. So the temperature of 35, sorry, this one, the value of 35 is coming from the temperature difference between 400 and 435 degree Fahrenheit. Okay, so when you calculate, use your scientific calculator and you should be able to get 1254.67 BTU per pound. So this is the example for steam tables. For steam table, you have two normal steam table, but then one is in SI unit, the other one is in British unit. Then you have another attachment for superheated steam table. Okay, now let's move on for the use of psychrometric chart. For psychrometry, it is the capacity of air for moisture removal, whereby it really depending on the humidity and the temperature. Psychrometry is a study of relationship between the air and its associated water, or it also can be the study of the behavior for the mixture of air and water. So what is humidity? Humidity is the measurement of water content in the air. So if let's say you go to a place whereby it is humid, when the local people say the area is humid. Humid meaning that there is a lot of water content in the air. Okay, and then we can calculate the absolute humidity, whereby the unit is in kilogram per kilogram. This one is the ratio. Humidity basically is absolute humidity. This one basically is dimensionless. They have no unit because the unit has been cancelled out. It's just a matter of the ratio. So it is the ratio of the mass for water vapor divided by unit mass of dry air. So air is said to be saturated with water vapor at a given temperature and pressure if the humidity is maximum, meaning that the air at that particular area is already maximized with water vapor. So it is known as saturated. Okay, so the humidity is maximum under these conditions. And if let's say further water is being added to saturated air, it must appear as liquid water in the form of mist or droplets. So for psychrometric chart, it is useful to determine changes in temperature as well as humidity for processes that involve loss or gain of moisture by air at room temperature. Alright, then when we move on to wet bulb temperature. Wet bulb temperature is another main feature for the psychrometric chart, whereby when we compare with the ordinary thermometer, whereby you have this mercury bulb, that one is known as dry bulb temperature, dry bulb thermometer. For the wet bulb temperature is the temperature that reached by a water surface such as that registered by a thermometer bulb surrounded by a wet wick when exposed to air by passing over it. Okay, so what is the wick? Wick is over here. Okay, this one. If dry bulb thermometer, so basically it is not being covered. The mercury area, the mercury bulb is not being covered. But then for wet bulb thermometer, the bulb over here is being covered with water and it is being submerged in water first in order to wet this particular cloth, okay, muslin cloth. The wick and therefore the thermometer bulb will decrease in temperature below the dry bulb temperature until the rate of heat transfer from the warmer air to the wick is just equal to the rate of heat transfer needed to provide for the evaporation of water from the wick into the airstream. Okay, so when we wet this muslin cloth, of course the temperature for the thermometer, for this thermometer, it will drop below than the normal thermometer of this dry bulb. For example, dry bulb, the thermometer is at 35, but then when you submerge the wet bulb thermometer into water, the temperature can go down to maybe around 28 or 25 degrees Celsius. Alright? Psychrometric chart is a chart of humidity against temperature. The two main axes are temperature of dry bulb and humidity. The saturation curve is plotted at this dividing the whole area into an unsaturated and two-phase region. Okay, so I will show you how to use psychrometric chart. Okay, this one is the psychrometric chart, whereby you can see at the bottom one here is dry bulb temperature. Over here at the bottom is dry bulb temperature. Alright, and then this one, the blue color, okay, this particular blue, 20 is for the wet bulb. Alright, and for the black color, it is represented for enthalpy. Okay, clear? And for the green color, this one is specific volume. They are specific volume. So we have how many parameter here? We have dry bulb, we have wet bulb temperature, dry bulb temperature, wet bulb temperature, specific volume, enthalpy, as well as humidity ratio. Okay. So now let's take a look for the example. Example number 1 for psychrometric chart. air at 60 degrees Celsius and 8% RH is blown through a continuous dryer from which it will emerge at a temperature of 35 degrees Celsius. Estimate the quantity of water being removed per kilogram of air passing and the volume of drying air required to remove 20 kilogram of water per hour. Alright, so this particular problem statement, it looks simple, but actually you need to have step-by-step of calculation. Alright, so the first one, air at 60 degrees Celsius and 8% RH, this one is considered as, this one 60 degrees Celsius, this one is considered as dry air. Dry air. So its humidity is 8%. So you need to look for the value of the weight of water inside of this air. Okay? And then it emerged at the temperature of 35 degrees Celsius. Emerge meaning that this particular air, it will exit from the system at the temperature of 35 degrees Celsius. Okay, so estimate the quantity of water removed per kilogram of air passing. For every one, so this one you have two questions basically. You have this one, number 1, and then this one, number 2. Okay, so estimate the quantity of water being removed per kilogram of air passing. Meaning that if let's say for 1 kilogram of air passing through the system, what will be the quantity of water going to be removed from the system? Okay, and then how much volume of drying air is being required in order to remove 20 kilogram of water per hour. So you have two questions, question number 1 and question number 2. Although this one looks simple, but you need to use psychrometric chart in order for you to solve the problem. And basically this particular problem will give you 10 marks. Okay, so the first thing first, you need to have your psychrometric chart in your hand. Please take a look for your psychrometric chart. Take out your psychrometric chart. Okay, so let's move on for the psychrometric chart first. For example, this one I end the show so that I can show you. Okay, now please have a look for your psychrometric chart. Okay, so for your psychrometric chart, you have several parameters that you need to consider. You need to pay attention for this one. Okay, at this side, this one is meant for dry bulb temperature. Dry bulb temperature. The value is in degrees Celsius. And then at the bottom part over here, okay, this one is moisture content. Okay, moisture content, and the value is gram per kilogram of dry air. Alright, and then at the top part over here, okay, this one is wet bulb or saturation temperature. Alright, wet bulb temperature. Do you get it? You can see that the value is 35, then you have 40, then you have 45 and 50. Okay, this value. Alright, then we move on for the percent of relative humidity. Is the curvy line over here. Okay, curvy line. Relative humidity is the curvy line. Okay, you can see this one, relative humidity, this value is at 40 degrees Celsius, 40%, and it moves down to 30%, 25, 20, then it goes to 15 and moving downward. Alright, followed by the value for specific volume. Okay, this particular part is specific volume. Alright, the line from your the line from your right to the left, this one is specific volume. Okay, the value of specific volume is 1.15, then it moves down to 1.10, this one is 1.05 and 1.0, and then after that is 0.95 at this particular line. Can you see it? Okay, so now what we are going to do is that you need to find the value of moisture content for the dry air. Okay, just now the problem statement, it mentioned air at 60 degrees Celsius and 8% RH. This one is dry air. This one is dry air. So what you need to do is, please take a look for your psychrometric chart. Okay, so what's going to happen is that you need to look for the value of 60 degrees Celsius. Okay, it's supposed to be here. Alright, so this one is 60 degrees Celsius. So mark the value, mark the line. Mark the line, this one. I cannot show you. Okay. This one. Mark the line at 60 degrees Celsius over here. 60. Okay, and then you need to find the intercept value between 60 degrees Celsius and 8% of relative humidity. So find the curvy line of 8%. Alright, so this one is the relative humidity. Okay, it goes down. And then look for the 8%. Okay, so can you see this one is 10% followed by 9, then this one is 8. Alright, so highlight this line as well, this curvy line, highlight this curvy line until it intercepts to 60 degrees Celsius. Okay, it's supposed to be here. The intercept value, bring it downward. Okay, bring it downward so that we are able to get to know the moisture content of the dry air. Bring it downward. Bring downward, then you will get the value at 10 gram per kilogram of dry air. This one, this value is 10. The moisture content of the dry air is 10 gram per kilogram of dry air. Alright, so that's why you can get from this particular problem statement. From this particular problem statement, the inlet air, the dry air just now, at 60 degrees Celsius and 8% relative humidity. So the humidity of the drying air, the moisture content of the drying air is 10 gram per kilogram. Or this particular value gram, you can convert to become kilogram per kilogram. Because remember just now, absolute humidity is the ratio between the mass of water and the mass of air. So this one is 0.01 kilogram per kilogram. Okay, so what will be the specific volume? Okay, this one is the first one. The first step, you find the moisture content. And then the second step, you need to find the specific volume. How to find specific volume? Again, you need to use psychrometric chart. Okay, so where does this specific volume? It is the line that is coming from your left hand side to the, from right hand side to left hand side. So this one is a value of 1.15. Then it moves down to 1.10, then it goes down to 1.05. Okay, and this one is 1.00, this one is 0.95. And again, by using the intercept point just now, the intercept point between 60 degrees Celsius and 8% of relative humidity, you need to draw a line similar like this 0.95 line. Okay, so what you need to do is, you get yourself your own ruler. Okay, this one is 0.95, correct? Okay, and then you need to draw your own line that passing through the intercept point. Intercept point of 60 degrees Celsius and 8% of relative humidity. Okay, so this one. Alright, then draw this line like this. Okay, so when you draw, so this one is, the line is 0.95, then the line that you've drawn is 0.96. The unit is meter cubic per hour. Sorry, the unit is meter cubic per kilogram of dry air. So this one is step number 2. Okay, so now we are going to calculate for the value of a wet air. Okay, so the first one, this one is dry air, then the following is a wet air. At temperature 35 degrees Celsius, this one is considered as wet air. So how do you want to get the moisture content of wet air? Again, you need to look by using psychrometric chart. Okay, but this time you are not going to use the temperature of dry bulb, but you need to use for the temperature of wet bulb over here, wet bulb. So you need to find for the temperature of 35. Okay, so find the value from wet bulb over here, and the temperature of wet bulb is 35 degrees Celsius. So which is the line for 35? It's like this. Okay, 35. 35, then you need to find the intercept point between the value of 35 and 8%. So 35, then you bring it down until it intercept with the value of 8%. Okay, it's supposed to be here. Can you see over here? Alright, so 35 and 35 degrees Celsius. Alright, 35, and it intercept at 8%. Okay, so bring it down to the line of moisture content. Okay, and you can see that actually it does not fall directly on the line of 20 gram per kilogram of dry air. Alright, actually it is next to the 20, to the value of 20. So how do you do that? How you are going to find the value for this 19.5 is whereby you can calculate for every line, it should represent value of moisture content, of each moisture content. So in between 10 to 20, they are being divided with how many lines? 1, 2, 3, 4, 5. So every line, it will represent an increment of the value by 2 of moisture content. So this one is 10, followed by 12, 14, 16, 18, and 20. But then the line that we found just now is in between 18 and 20. But it does not really fall on the 19. It is around 19.5. Okay? So make sure you need to draw the line properly and place your ruler properly as well. Alright, so this one. So the value for the moisture content of wet air is 19.5 gram per kilogram. And you need to convert the value gram to become kilogram. So it becomes 0.0195 kilogram per kilogram. So the water removed for every 1 kilogram. Okay, per kilogram. Mana datang? Where does it come from, this per kilogram? It is coming from here. Okay, this per kilogram. Okay, so for every 1 kilogram, the moisture content is 19.5 gram or 0.095 kilogram. This one is meant for wet air. For dry air, for every 1 kilogram, it is having moisture content of 10 grams or 0.01 kilograms. So how you supposed to answer for question number 1? The water is being removed. You need to minus the value of moisture content in wet air minus by the moisture content in dry air. Okay, so that's why it becomes 0.0195 minus by 0.01. So you will be able to get the value of 0.0095 kilogram per kilogram of air. This one, you solve the question for question number 1.